Question 1. The rate at which water flows out of a pipe in gallons per hour is given by a differentiable function r of time t. The table below shows the rate as measured every 3 hours for a 24-hour period. Use a left endpoint Riemann sum with 4 subdivisions of equal length to approximate the integral from 0 to 24 of r of t. Okay, we know we need to go from 0 to 24, so let's go ahead and make a chart for that. And then to figure out what to go by, let's do 24 minus 0, which would give us 24. We need 4 subdivisions, so if I divide by 4, I will get 6. So that means I need to go by 6s. All right, since I'm going by intervals of equal length and I'm going by 6s, I can just put a 6 on the outside. And then I just need to figure out the left endpoints. So between 0 and 6, 0 is on the left, and the y value there is 9.6. And then plus, between 6 and 12, 6 is my left endpoint, the r value there is 10.4. And then between 12 and 18, 12 is my left endpoint, the r value there is 11.4. And then between 18 and 24, 18 is my left endpoint, the r value there is 10.7. When I calculate that out, I should get 255. And since I was in gallons per hour, when I take the integral, the rate drops out, so it's no longer per hour. So my units now are gallons. If somebody asked me a question about this, I would say we've got water flowing out of a pipe. I would say there were 255 gallons of water flowing out of the pipe during that 24-hour period. Question 2. Selected values of a continuous function are given in the table below. Using 6 subintervals, find the right endpoint sum for the integral from 0 to 12 of f of x. Okay, I do notice that if I used equal subintervals, the numbers that I would need would not be on the chart. I do notice the numbers do not go by equal intervals. So instead of putting a number on the outside, we'll actually have to take care of each interval separately. So I'm going to circle my different intervals here. 1, 2, 3, 4, 5, 6. So I do have 6 of them. For each one, I'll just have to calculate the width of each one separately. The width of this first one would be 1 because the distance between 0 and 1 is 1. And then the right endpoint between that would be 18. Okay, my second one, the width between 1 and 4 would be 3. The right endpoint is 12. And the next one, the width between the two is 1. And then the right endpoint is negative 4.5. On the next one, the width, I forgot one, sorry. Between 4 and 6, the width was 2, the right endpoint was 8. My next one was 1 times negative 4.5. Then the next one between 7 and 10, the width would be 3, and then the right endpoint would be negative 30. And then the last one, the width would be 2, and my right endpoint is negative 34.5. So if I were to calculate that all out, I should get negative 93.5. Okay, number 3, use the trapezoidal rule with n equals 4 to approximate the integral from 4 to 7 of the curve 5 over x plus 3 to the 4th dx. All right, I'm going to start with making my chart. I know I need to go from 4 to 7, and I need 4 intervals. So to figure out what I should go by, I'm going to do 7 minus 4, which would give me 3. And I need to separate it into 4 different parts. So I'm going to have to go by 3/4, or I'm going to actually go by 0.75, so I think that's a little easier. So I'll have 4.75, 5.5, 6.25, and then 7. Okay, when I use the trapezoidal rule, it's always 1/2 times the height. The height would be what I'm going by, which would be 0.75. And then on the inside, remember we actually will use all of these values. I will find f of 4. My insides get multiplied by 2, so I'll have 2f of 4.75 plus 2f of 5.5 plus 2f of 6.25, and then the last one does not get multiplied by 2. Okay, after evaluating this, I should end up getting 0.003 as an answer. I would strongly suggest on this one, just to make your life easier, to actually plug this function in for your y1, and then when you type it in, you could do y1 of 4 plus 2y1 of 4.75, and so forth. And if you needed help doing that, please just ask me and I'd be more than happy to show you again.